Welcome to my channel Tech Tic Tac Toe. Today I will discuss about stack in detail with codes. In our previous video I have discussed about the concept of stack. I will give the link of that video in the description of this video, so you can go for that video and return in this video, or I am giving you some reminder of that concept. Stack is a linear data structure. It performs operations at one end, that is LIFO or FILO. That means last in first out. The last item inserted will be first item to out, or first in last out. That means the first inserted item will be the last item to be out. A real example of stack is the stack of plates in the restaurant, where we can take plates from the top and they also add fresh plates at the top only. So this is the example of stack. The main important things in stack is push, pop and top. Top is the position from where we can insert or delete an item. Push is the insertion of an item in the stack, and pop means deletion of one item at the top, from the top. So implement using array or linked list. We can use array to implement stack. This will look like this. We can add item here, or and then we have to add delete item from here. If we add item here, we have to delete item from here. In linked list, we have to delete and insert item from here only. This is the first item inserted in the stack, and then the last item inserted will be here, and the first item to be out is from here. So I will discuss the two methods of inserting and deleting of item from stack using array and using linked list. So in first method, we are going to insert an item in this position. So to do this, we have to shift these elements to this portion, then free this portion, then we have to add one item. Now when we think about inserting an item, we have to first check if the array is full or not. So if let's consider n is the number of item in the array. So if number of item is greater than equal to size, then print stack overflow, then return from this function. Otherwise we have to do these things. If the array is empty, then index will be 0, top will be 0, so it will not go inside this loop. So stack of top will be, that means 0 position will be the new element, and n will be n plus 1, that means 1. So one item at the stack. If there are 4 items, consider there are 4 items in a stack. Now index will be 4, top will be 0. Now until top index is not equal to top, so while index not equal to top, that means while index is now 4, so it is not top, so it will go inside this. So stack of index, that means index starts from 0, so 0, 1, 2, 3, 4. This position will be filled with index minus 1, this position, so this will be this. Now index will be 3, so here index minus 1 will be here, so 24 will be here, 30 will be here, 18 will be here. Now index equal to 0, so it will not go inside this loop. Then stack of top, stack of 0 will be filled with new element, then number of element will be number of element plus 1, so n will be 5. Now when we insert 5, we have to shift these cells with this loop, so this will be shifted here, then stack of top will be 0 blank here, new element 5 is inserted here, then n equal to n plus 1, that means 6. So now if we want to again insert one element, then it will go into this if position. N is greater than equal to size, so n is equal to 6, size is equal to 6, so it will print stack overflow, then return from this function. So this way we can push an item in a stack from this end. Now when we insert in this end, we have to delete from this end. So now when we want to delete an item from a stack, we have to check if the stack is empty or not. If number of element is 0, then the stack is empty, then we have to return from the function. Otherwise, top equal to 0, index equal to top. That means index equal to 0. Print stack top. So we have to print this portion, or we can store it in a variable, what we want to do. So now here we print this stack of top, so this item will be deleted now. Now index of until n, that means until 4. Stack of index, that means index is now 0. 0 is here, will be replaced by index plus 1. So this will be replaced by this. Now index equal to index plus 1, that means this portion, this position is replaced by index plus 1, that means this position. Now index equal to index plus 1, that means this position will be indexed by index plus 1, replaced by index plus 1, that means 86 will be here. Now index equal to 3. So in case of 3, stack of index is here, this will be copied here, so this is be freed. Now index will be index plus 1, that means 4. Here index is not less than n. N is equal to 4, index is equal to 4, so this condition not holds, so it will not go inside this position. So we have to do this portion only. Then we can decrease the size of number of element. So number of element will be now 3. So in this case, again if we want to delete an item, 30 will be deleted, then 24 will be here, 86 will be here, blank will be here, then the loop ends and number of elements will be 2. Then 24 will be deleted, 86 will be here, blank will be here, end of the loop. Then again 86 will be deleted, there will be blank stack. When there will be blank stack, the n will be 0, then it will go into this if portion, stack is empty, then return from this function. So this way we can pop using method 1. Now method 2, as we are using array, we can access this position directly. So in this case we consider first element inserted is 18, then 30, then 24, then 86. Now we want to add 10. So first we have to check if the stack is full or not. If the stack is full, that is n number of element is greater than equal to size, then it will print stack overflow, then return from this function. Otherwise, top equal to n minus 1, that means top equal to 3. Now stack of top plus 1, that means stack of 4. Stack of 4 means 0, 1, 2, 3, 4. This position will be new element and n will be n plus 1. That means the number of elements present in the array will be incremented with 1, that is 5. Now when we enter another item, we have to enter in this position, and then number of element in the stack is 6, so it will be greater than equal to 6 size, so it will print stack overflow. So this way we can insert an item at the at this position. So when in method 2, when we are inserting in this position, we have to delete from this position. So the pop function will be check first if it is empty. If it is empty, the stack is empty, then you have to return from this function. Otherwise, top equal to n minus 1. That means top equal to n equal to 4, top equal to 3. That means this position. Print stack top, this will be printed, then n equal to n minus 1. So number of element will be 3. So we do not consider here, we have set top here, so we can do not access this position anymore. Now again we have to delete another item. We have to delete 24, as the size of the number of elements present in the array is 3, we know. So top will be 2. So print stack top, that means 2, 0, 1, 2. It will be printed and the number of element will be 2. Now 30 will be deleted, number of element will be 1. Now 18 deleted, number of element will be 0. Then it will be print empty stack, then return. So this way we can delete an item from the stack in method 2. Now using linked list, how can we implement stack? When we using linked list, we do not have to check if it is full or not, because linked list is not limited. We can insert as many as we want. So new pointer will be new node. So new nodes info will be new element, and new pointer dot link will be top. That means this will be linked to top. So here, if this is the first element, top will be null, so here it will be null, and top will be new ptr. This means this address will be top. Again, when we want to add one item, we have to insert in this position. Otherwise, if there are 3 elements, so this is not 30, this is the address of this 30. So here we first define a new element, then insert the element in the node's info part, and link part will be top. This part will be this address of this node will be the top, so address of this will be here, and top will be the address of this element. So here, after inserting 10, the address, this will be the previous top, so this previous top will be address of this node, and top will be now address of this node. So this way we can use linked list to represent stack. Now when we delete an element from stack, we have to check if the linked list is empty. If top equal to null, then stack is empty. Otherwise, we have to omit this portion. So top will be the address of this address. So we will print the info, or we can store it in a variable what we want to do with the deleted portion. Then top will be the link of this top. Now previously top will be the address of this location, now top will be the address of this location. So the address of this is stored here, so top store the address of this location. So in this way we can delete a node from linked list. Now I think you all understand. If you have any queries or need any detail, let me know in the comment section. If you like this video, subscribe to my channel. Thank you for watching this video.